Guys, so in this video what we're gonna learn, हमें देखना है we're studying linear algebra. अब हमें ये करना है कि हमारे पास first equation है, ये second equation है, ये third equation है. So what we have to do is that we have to, in order to check that these equations are having a point of intersection, so having a common point of intersection means that your equations are, let's say this is equation 1, this is equation 2, this is equation c0. So we have a solution available for this equation. Okay, so what we're gonna do is we have to check if the solution exists or not. What we did was we multiplied the first equation with 2 and it got 18, then we solved it simultaneously, then we got 17, and then we finally solved this further, we got value y equals, okay, then what we did was z, the value of z was 3, y, the value of y was 2, and x was 1. Okay, so now what we're gonna do is solve the following solves. Okay, so we assume that after the solution this was the solution set, so this proves that the solution set exists. But when we involve the fourth equation, so these four solutions were not providing a solution common point. So what we did was we had a statement, this question cannot be solved, this equation cannot be solved. Okay, now what we're gonna do next is how to reduce a matrix into row equivalent form and reduced row equivalent form. Okay, reduce the following matrix into row equivalent form and reduced row equivalent form. So what our ultimate product that we want to have this identity matrix over here, we want to have this identity matrix over here, so we have to go all this process. So I'm going to try to explain this process a bit. So what we did was we have this A over here, 2 1 1 2 and row 1 2. What see, these are the rules that we have to keep in mind. We cannot go out of these rules. Change any two rows, multiply row by a non-zero constant, multiply row by non-zero constant, and add to some other row. We'll get to this in a while. Okay, so but you have to keep these three rules in mind. I'm going to read it again. Change any two rows, multiply row by a non-zero constant, multiply a row by non-zero constant, and add to some other row. Now for a time being, forget about this. I'm gonna come back to this, so be patient. Okay, concentrate what I'm trying to say right here. Leading one of the first row, we see what we did was we interchanged row 1 with row 2. So it was 2 1 and 1 2. What we did was we interchanged these rows. 2 1, see, this 2 1 comes in here and this 1 2 comes in here. Okay, so 1 is achieved. Okay, this one right here is achieved. Now what we have to do is we have to multiply this row 1 with -2 and add into row 2. Okay, so 1 and 2, 1 multiplied by -2 plus row 2 0. Okay, getting my point? Row 1 multiplied by -2, that means this thing becomes -2 and this thing becomes -4. -2, -4, -2, 2, -2, 0. This was -4, -4, and this 3 right here. And this sort of adds, so what we're gonna get 1. Hold on a second, I explained a bit wrong. See, -2, this is negative, consider this as negative. I'm gonna try to explain it with green. See, negative 2, and consider this as negative 4. Negative 2 plus this 2, 0. 1 minus 4 minus 3, comma point. Now we're going to move on. Now what we can do is see, this is following this rule. You can multiply a row by a non-zero constant and add it to some other row. So according to rule 3, this is valid, and according to rule 1, this is valid. Now we're going to apply rule 2 and see. Now we want to achieve our ultimate final goal is to achieve this thing. So what we're going to do is negative 1 by 3 multiplied by row 2. Why we did this? So that this 3 and this 3 could get cancelled, and negative negative positive, that means 1 could be achieved over here. So negative 1 by 3 multiplied by 0 is 0, but negative 3 multiplied by negative 1 upon 3 accounts for 1. REF form achieve ho gayi. What is the reduced equivalent form? Now we'll further reduce this thing down. So what we do is we have this row 2 multiplied by negative 2 add into R1. Row 2, this row 2 multiplied by negative 2. Here is the row 2. Okay, this is row 2 multiplied by negative 2. Negative 2 multiplied by 0 is 0, and negative 2 minus 3. Negative 2, see, negative 2 multiplied by 0 becomes 0. So this thing becomes 0. It's actually a 0 over here. Yes, 0 is here. I made a little correction over here. Okay, and then negative 2 and add it into this row, so it becomes 1. Okay, so 1 minus 2 is minus 1. Minus 1 plus 2, and the answer becomes 1. Okay, so this is your reduced equivalent form and reduced row equivalent form. So this is your reduced row equivalent form. Reduced row equivalent form. Okay, but we have to remember that this conditions has to be satisfied.